హలో సార్. సార్ లైట్గా వినబడుతుంది, కానీ మీరు షేర్ స్క్రీన్ చేసే వరకు ఉండరా? నాకు యాక్చువల్లీ నేను మొబైల్తో లాగిన్ అవ్వను. ఇది నాకు ల్యాప్టాప్లో సేమ్ ప్రాబ్లం చూపిస్తుంది. హలో సార్. సార్ అదే రావట్లేదు సార్. అది నా మెయిల్ షేర్ స్క్రీన్ అంటే మెయిల్కి వెళ్ళట్లేదు, ఈవెన్ మెయిల్లో ఉన్నాయి. సార్ నాకు అర్థం కావట్లేదు. వాట్సాప్ లో ఉన్నాయి, ఎలా చూపించాలి? వాట్సాప్ లో ఉన్నాయి అట్లీస్ట్. యాక్చువల్లీ షేర్ స్క్రీన్ అంటే మైక్రోసాఫ్ట్ వన్ డ్రైవ్ అని, గూగుల్ డ్రైవ్ అని, బాక్స్ అని, ఫోటో అని, డాక్యుమెంట్ అని చూపిస్తుంది. ఏది స్క్రీన్ అంటుంది, కెమెరా అంటుంది, షేర్ వైట్ బోర్డ్ అంటుంది, వెబ్ యూఆర్ఎల్ అంటుంది. ఏది పెట్టినా రెస్పాండ్ అవ్వట్లేదు సార్. నాది డ్రైవ్ లో లేదు, నాది మెయిల్ లో ఉంది సార్. వెళ్తుందా? ఓకే సార్, నేను ట్రై చేస్తున్నాను. ఒక్క నిమిషం. ఇదేంటి సార్, మళ్ళీ సైనింగ్ అప్ అంటుంది. మొబైల్లో అన్నీ చేసి పెట్టుకున్నాను, ల్యాప్టాప్లో అదేమో రావట్లేదు సార్. యాక్చువల్లీ మంచి కనెక్ట్ చేస్తున్నాను, అయినా అన్నీ వస్తున్నాయి, అన్నీ డౌన్లోడ్ చేసుకున్నాను, అన్నీ వచ్చాయి. ఇది ఎందుకు రావట్లేదు అర్థం కావట్లేదు. సిస్టమ్ లో మొత్తం రెడీగా ఉంది సార్. జస్ట్ నాకు అది ఎక్కడ ల్యాప్టాప్ డైరెక్ట్ జూమ్ ఓపెన్ చేయాలా? ఇప్పుడు ఓపెన్ చేసినా కూడా సేమ్ ప్రాబ్లం చూపిస్తుంది సార్. ద సైట్ కెనాట్ బి రీచ్డ్ అని. ఎందుకు అలా చూపిస్తుంది అర్థం కావట్లేదు. అది మొబైల్లో అయితే ఓపెన్ చేస్తుంది. జూమ్ ఓపెన్ అయ్యాను, సైన్ ఇన్ అవ్వాలా? ఉంది సార్. పర్సనల్ది పెట్టనా? ల్యాప్టాప్ లోనే ప్రాబ్లం అనుకుంటా సార్. అనేబుల్ టు కనెక్ట్ అని చూపిస్తుంది. ఇంటర్నెట్ కనెక్షన్ ఉంది, చూస్తే ప్రాబ్లమే లేదు. చాలా కనెక్టెడ్ అని చూపిస్తుంది సార్. ఒక్క నిమిషం, నేను పిక్ పెడతాను. సేమ్ చూపిస్తుంది ఇది నాకు. ఎందుకు మీ వాయిస్ క్లియర్ లేదు, నాకు అర్థం కావట్లేదు. హ్మ్. సార్ నాకేం అర్థం కావట్లేదు. ఐల్ ట్రై వన్ మోర్ టైమ్ సార్. కేఎంఐటీదే వస్తే మొబైల్‌లో ఈజీ అయిపోతుంది. సార్ మేబీ ప్రాబ్లమ్ అది కూడా అనుకోవచ్చు. చెప్పండి. సార్ నాకు వాయిస్ క్లియర్ లేదు. కాల్ చేస్తారా? నాకు సైట్ ఓపెన్ అయితలేదు. ఇష్యూ అవుతుంది ఎందుకో.
Good morning, students. Actually, there is some technical issue from Sarita madam's side, so we are starting in just couple of minutes. Okay.
Sir, my voice is audible now?
I am starting to share my screen.
Okay. Yeah. Good morning, everyone. Some network issue, delay for that. I'm sorry for that. Now I'm going to explain the unit 4 important one of the important question. The question is, show that the vector x square minus yz I bar plus y square minus z j bar plus z square minus xy k bar is irrotational and find its scalar potential Here, that is a very important question. This is scalar potential we need to calculate. In that, first of all, we need to show that it is irrotational. There's some sound is coming. Hello?
Hello. Yes.
Some sound is getting, sir.
Now it is okay, ma'am.
Okay, sir. Now it is okay. Okay. So it is irrotational. We need to find its scalar potential. For showing of irrotational, we need to calculate curl f bar equal to 0. So for curl f bar equals to finding its determinant, that is I bar, according to the definition, I bar, j bar, k bar, dou by dou x, dou by dou y, dou by dou z, x square minus yz, x square minus zx, z square minus xy, that is y square, second one. So evaluating according to determinant I bar, dou by dou x of evaluation is clear. That is next slide, sir. So finding its partial derivatives with respect to x, y, z, will get the value as 0 bar. I bar of 0 minus j bar of 0 plus k bar of 0. So we'll get that 0 bar. So f bar is irrotational. And in this next statement, what we have is that we know that because if f bar is irrotational, we know that if f bar is irrotational, there will be always exist a scalar function phi of x comma y comma z such that f bar is equals to grad phi. This statement we have to remember. This is a note point after completion of the curl we have. From there we are taking to calculate scalar potential. Here phi is called scalar potential of f bar. So how to calculate this means, next slide, sir. So f bar is equals to grad phi. So grad phi, this is we are taking as grad phi is equals to f bar. According to the grad phi definition, that is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z, which is equals to x square minus yz I bar plus y square minus zx j bar plus equating what is f bar is given. So now comparing both sides coefficients, that means I bar coefficient, j bar coefficient, k bar coefficient. So first comparing I bar coefficient, so left hand side dou phi by dou x is equals to right hand side, which is equals to x square minus yz. Here we need scalar potential phi. So we are integrating both sides. So with respect to x integration, so left side will get phi is equals to integration of x square minus yz with respect to x. So x square integration is x cube by 3 minus yz is constant with respect to x integration is xyz plus some constant will get. That constant value is in terms of y and z. So that is what we are mentioning as f1 of y comma z. and considering as equation number 1. Similarly, now comparing the coefficient of j bar both sides, so we'll get dou phi by dou y is equals to y square minus zx. This is implies integrating because we need scalar potential phi, so that which is equals to phi is equals to y square integration is y cube by 3 minus here zx is constant with respect to y integration. So we'll get as x minus xyz plus some constant. That constant is in terms of z and x. So that is f2 of x comma z, considering as equation number 2. Similarly, k bar coefficient comparing and integrating will get phi is equals to z cube by 3 minus xyz plus f3 of x comma y. So these three equations which indicate phi value, that is scalar potential value. So this equation 3 we are considering as writing phi value, which is not repeated values we need to write, that is x cube by 3 from equation number 1, that is 1 by 3 of x cube, plus from equation number 2 y cube plus equation 3 z cube, and here a minus xyz is repeated twice, so that is we need to consider as one time, so that is minus xyz, and first equation, second equation, third equation constant part is there. That constant part, instead of writing in terms of yz, xz and xy, just simply we are writing as constant. So this phi value is gives the required scalar potential function. So what is it is, we need to find compulsory, the question it is compulsory for essay mark question, that is for the long answer. So that here irrotation we need to prove, and if it is irrotational, we know that there exists a scalar point function such that f bar is equals to grad phi. So grad phi is equals to what is given from vector f bar. We are equating I bar, j bar, k bar coefficients, and integrating will get phi as in three equations. So equation 3, that from 3 equations we need to write phi value, that is required potential function as non-repeated values, and that plus constant gives the required scalar potential. So next slide. So next topic, after completion of the divergence, gradient and curl, there is one of the operator is there, that is Laplacian operator. This Laplacian operator is del square, it is symbolically represent, and what is the inner meaning of del square is del dot del phi. Phi is any vector point function or scalar point function. We are finding del dot del phi, which is equals to, first del dot we are representing in summation form, summation I bar dot up to there, that dou by dou x is del dot. Then del phi is, already we have del phi, that is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. So which is equals to inner differentiation with summation. So we'll get the summation form of dou square phi by dou x square, that is nothing but dou square by dou x square plus dou square by dou y square plus dou square by dou z square of phi, that is dou square by dou x square. That term is symbolically represented as del square. So that is del square phi. This del square is called Laplacian operator. This del square is called Laplacian operator. So next slide. So depending on this Laplacian, we have two properties or the node points, that is del square phi is equals to del dot del phi, that is nothing but del dot we know that divergence, del phi is gradient. So divergence of grad phi is nothing but Laplacian operator. And the next one, if del square phi is 0, phi is said to satisfy Laplacian equation, that is you have this is del square phi is equals to 0, then phi is called harmonic function. This it is useful for your higher classes, that is del square phi equals to 0, here phi is called harmonic function. So next slide. So after completion of this three topics, the fourth topic of this chapter is vector identities, that is theorems. vector identities or theorems here. The first theorem is if A bar is just I'm going to explain the statements only. Which theorems are important? I'll give you the number. Please go through that, and if you don't have understanding of that, um, call or ask your CR to my number. They will give and you call. I will explain that because in this theorem we have theorems. Look at first theorem is if A bar is a differentiable function and phi is a differentiable scalar function, then prove that divergence of phi A bar is equals to gradient phi dot A bar plus phi into divergence of A bar. So divergence of phi we need to take, that is symbolically represent as del dot phi A bar, and summation form we are representing summation I bar dot dou by dou x is the value of del dot, then inside what we have is phi A bar. So that is UV method of differentiation. Next step we are applying, that is U into V plus that is dou U by dou V, dou U by dou X into V plus dou V by dou X into U. That is in the UV method of differentiation, dou phi by dou X A bar plus phi into dou A bar by dou X. Then this dot product we are applying inside, that is summation I bar dot dou phi by dou x A bar plus summation I bar dot dou A bar by dou x into phi. So here I bar dot dou A bar by dou x we are writing together means it is a vector and the phi is scalar. So that is the next time we are writing I bar dou phi by dou x together dot A bar plus I bar dot dou A bar by dou x into phi. This gives the required statement of the theorem number 1. So next slide. So according to the next theorem, that is curl phi A bar is equals to grad phi cross A bar plus phi curl A bar. So here curl phi A bar we are considering, that is del cross phi A bar. Del cross we are writing as summation form I bar cross dou by dou x. That is del cross is summation of I bar cross dou by dou x. If it is del dot is summation of I bar dot dou by dou x. So that is summation form we are writing. Similarly, third step is similar. We are applying UV method, dou phi by dou x A bar plus dou phi into dou A bar by dou x. Then this multiplying I bar dou phi by dou x cross A bar plus summation I bar cross dou phi by dou x into phi. So according to the given statement, we are writing like that. So that is gives a dou phi cross A bar plus del cross A bar, that is curl A bar into phi. So next slide. So next theorem, that is grad A bar dot B bar is equals to B bar dot del A bar plus A bar dot del B bar plus B bar cross curl A bar plus A bar cross curl B bar. So in this we are taking left hand side one of the values, one of the A bar cross curl B bar. So according to this, A bar cross del cross B bar. So curl B bar is del cross B bar. So next step, this del cross we are writing in summation form, that is summation I bar cross dou by dou x of B bar. So B bar is one of the terms, so that is what inside writing as dou B bar by dou x. Then this summation writing outside, summation which is equals to A bar cross B bar I bar cross dou B bar by dou x. So according to the property A bar cross B bar cross C bar, evaluating that step, so we will get as A bar dot C bar into B bar minus A bar dot B bar into C bar according to the A bar cross B bar cross C bar property. So that is the next step, and then writing summation I bar a bar dot b bar dou b bar by dou x minus summation evaluating to the next value a bar dot summation I bar dou by dou x of b bar, writing b bar outside of that. Next slide, sir. So what is giving a bar cross curl b bar is equals to summation I bar of a bar dot dou b bar by dou x minus a bar dot del of b bar. This we are considering as equation number 1. Similarly, we are writing for b bar cross curl a bar. That gives us equation number 2. So now adding equation number 1 and 2. So left hand side is a bar cross curl b bar plus b bar cross curl a bar is equals to summation I bar of a bar dot dou b bar by dou x minus the term a bar dot del of b bar plus the second equation we are adding summation I bar of b bar dot dou a bar by dou x minus b bar dot del of a bar. So next slide. So this is evaluating as what are the negative terms are there, writing to the left hand side, and the remaining value is summation I bar of a bar dot dou b bar by dou x plus b bar dot dou a bar by dou x. This is the UV method, so writing in the shortcut form summation I bar of dou by dou x of a bar dot b bar, that is del that is del. There is a no in between I bar and dou by dou x, there is a no dot product. So if it is dot product, it comes under divergence. So but it is only del, so del of a bar dot b bar. You have to remember this one as a formula wise also. So these are all the explanation what I am giving for the vector identities. I'm sure you are not able to understand that, because that are the theorems. If you know all the properties and the symbolical representation of this divergence, curl and gradient, then only you're able to understand. Otherwise it is like that only. So that is, you go through the properties once. If you have a doubt, please pin. Otherwise practice those who have here mentioned questions are there. You practice that, that is enough. So just I'm reading that we are going through the statements now. So next theorem is the divergence of a bar cross b bar is equals to b bar dot a curl a bar minus a bar dot curl b bar. This is also we are evaluating left hand side and the symbolical representation and finding its proof. So next slide. So next theorem, theorem number 5, that is curl a bar cross b bar is equals to a bar divergence b bar minus b bar divergence a bar plus b bar dot del a bar minus a bar dot del b bar. So here we are taking left hand side and using the property of symbolical representation, and it is evaluating as UV method a bar cross b bar as UV method evaluation and simplifying the summation to the both the terms, then it is comes under a bar cross b bar cross c bar. So applying that and evaluating. So next slide. And evaluating and writing in the notation form, we'll get the answer here. So next slide. Next, theorem number 6, prove that curl grad phi is equals to 0. This is very easy and simple one. Here phi is a scalar potential function we are taking. That grad phi we already know, that is I bar dou phi by dou x plus j bar dou phi by dou y plus k bar dou phi by dou z. Finding curl of this grad phi. So curl of grad phi writing in the determinant form I bar, j bar, k bar and respective values. Evaluating the determinant, obviously we'll get the 0 bar, because we know that curl of f bar equals to 0. This is curl of grad phi is 0. We have grad phi is always irrotational. That is the one. So always we'll get the as zeros. So next slide. And this is also simple. Divergence of curl f bar equals to 0. For that we are considering as f bar is some function, some vector f1 I bar plus f2 j bar plus f3 k bar. Finding curl of this f bar, writing in the determinant form I bar, j bar, k bar respective values, and evaluating, we'll get the values that values are partial differentiation with respect to x, y, z, that becomes zeros now. Evaluating as a dou square f by dou x square, all this. Okay, then so next slide. So f3 is a function evaluating dou x by dou y. So in f3 it is dou square f3 by minus dou y by dou x, that is going to be get cancelled and we'll get the value as 0. Since always divergence of curl f bar equals to 0, therefore curl f bar is always solenoidal, because we have a solenoidal definition. If f bar is solenoidal, divergence of f bar is 0. So here what we are getting, divergence of curl f bar is 0. Then curl f bar in this is always solenoidal. So next we have just these two ones, that is that if f and g are two scalar point functions, prove the divergence of f del g is equals to f del square g plus del f dot del g. And then the last theorem, that is del cross of a bar equals to del of del dot a bar minus del square a bar. In this, theorem number 1 is important. Theorem number 1 is important, and 2 slightly. Then theorem number 4 important and 9 important. Once you go through this, practice this, then it is easy for you. Okay. Sir, with this we completed 4th unit. Can you start the 5th unit, sir? So after completion of the 5th unit only, we will discuss important questions on the 4th unit. Today some network issues there, but I downloaded and I kept on my desktop. But it is sharing is impossible now. So that we are going for the next unit discussion. Up to now we discussed vector differentiation. Now we are entering to the vector, how to integrate the vector. In this we have the topics in this are line integral, surface integral, volume integral, and Gauss divergence theorem, Green's theorem, Stokes theorem. So in this only short answers expectation of this anyway you have the pattern is different because you know totally 5 unit 8 questions are there, all long questions only, and slightly if it is asking definition and perspective regarding that problem. So in this all the topics what we have 6 topics, the 6 topics are covered for the long answers only. So that first we are entering to the line integral. The next line. So according to the try to understand this definition. Totally this is under imagination. So an integration which is evaluated along the curve C is called line integral. So suppose a curve A to B is there. So if it is integrating along this line, that is called line integration. Let f bar be a vector point function defined at each point of the curve. So in that each point of the curve, vector point function f bar is defined, and f bar we are considering as f1 I bar plus f2 j bar plus f3 k bar, and r bar is xi bar plus yj bar plus zk bar. That is integral C, integral over the curve C, f bar dot dr bar. Dr bar is nothing but xi bar plus yj bar plus zk bar derivative. That is dxi bar plus dy j bar plus dz k bar. And here we are applying f bar dot dr bar. So dot product is applying. So we'll get I bar dot I bar equals to 1, J bar dot J bar equals to 1, K bar dot K bar equals to 1. So F bar dot dr bar becomes F1 dx plus F2 dy plus F3 dz. So integral over C F bar dot dr bar is equals to integral over C F1 dx plus F2 dy plus F3 dz. Here this definition, this is along the curve AB. Along a curve, the integration is evaluated. This is called line integration. So along the curve, in each point, the vector point function is defined, and that f bar and this position vector r bar, that is xi bar plus yj bar plus zk bar, that gives integral over c f bar dot dr bar value is indicates line integration value. So next slide. So next is definition is circulation. Here this is one of the term we are using in problems. That is, if V bar represents the velocity of a fluid particle and C is closed curve, then the integral, next slide sir, integral over C V bar dot dr bar is called circulation of V bar around the curve C. That is integral over C V bar dot dr bar. If it is V integral over C V bar dot dr bar is 0, then the field V bar is called conservative. That means no work is done and energy is saved. Because the circulation is 0, then there is no work is done and the energy is conserved. So if the circulation of V bar around every closed curve in a region D vanishes, then V bar is said to be irrotational in capital D. So in line integration, we are using, instead of finding so and so value, instead of finding line integration direct problem, we have this type of questions are also in the under line integration. That is, evaluate circulation of so and so function or so and so vector, or also work done problems under this line integration we have. So that terminology we are here optimum the terminology here. So next slide sir. So next terminology under line integration is work done. So work done by force. Here F bar represent the force vector acting on a particle moving along arc AB. Then the work done during a small displacement delta R bar is F bar dot del R bar, delta R bar. Hence, the total work done by F bar during this displacement from A to B is given by, so next slide, integral A to B F bar dot dr bar. This is integral AB F bar dot dr bar. This is also same like line integration, but it is integral, instead of writing integral over C, here we are writing as integral A to B F bar dot dr bar. So if the force F bar is conservative, then we know that F bar is equals to del phi. The work is independent of the path and vice versa. In case curl F bar equals to 0, here phi is called scalar potential. Same terminology what we are have in the previous unit. Same, that is curl F bar equals to 0, then curl grad phi equals to 0. This is phi is called scalar potential. So under line integration, we have the same line instead of asking question directly, calculate find the integral over C F bar dot dr bar. So under this we have two more terminology you are using. One is circulation and one is work done. This work done problems are very, very important. Instead of asking the question directly, indirectly asking about the work done here. Clear? Even whatever it may be, the formula is same under line integration. You don't worry about the definitions because the definitions is never asked, but only. Integral over C f bar dot dr bar. So firstly we are calculating f bar dot dr bar. That gives, so next slide. Here f bar dot dr bar is 3x cube minus 6yz dx plus 2y plus 3xz dy plus 1 minus 4x xyz square dz. This is the total f bar dot dr bar what we need for integration. We calculated and keeping aside. But here the, and then what we are need to concentrating on limit, and here limit we are applying, we need to take three limits, that is x from 0 to 1, y from 0 to 1, z from 0 to 1, and we here only we have line integration only, not volume integration or surface integration is there. So that what we are doing is according to the given curve we need to evaluating this f bar dot dr bar in one parameter. Already in the question they are given as x is equals to t, y is equal to z is equals to t cube. So using of this parametric equation, we need to calculating dx, dy, dz term. So with respect to dx is becomes dt, dy becomes 2t dt, dz becomes 3t square dt. Now we need to evaluating wherever x is there, replace with t, y is there, replace with the t square, z is there, replace with the t cube, dx is there, dt, dy becomes 2t dt, dz becomes 3t square dt. So f bar dot dr bar totally converted into one parametric form, that is t. But we need to calculate t limits. So for that we need to check three equations. So one is, first equation is x is equals to t is given. If x is 0, t is also 0. If x is equals to 1, t becomes 1. So that is what here t we are writing as 0 to 1. But we need to consider both the equations, all the equations. One another equation is y is equals to t square. If y equals to lower limit is 0, y is varying from 0 to 1. So substituting in that equation, y is 0, t becomes 0, but y is 1, t becomes plus or minus 1. So what the satisfaction condition is, 1 is 0 to 1 and 0 to minus 1, keeping aside. And the similar way of z is equals to t cube also, it will get 0 t varying from 0 to 1 and t varying from 0 to -1. So most satisfying equation in these three parametric equations are 0 to 1. That is what we are considering the value. T is varying from 0 to 1. So integral work done value is integral over c f bar dot dr bar integrating to 1. So already here we have 3x minus 6yz. So that is x place we need to substitute t. 6 into y is t square, z is t cube. So it becomes 6 into t power 5. dx becomes dt. Then 2 into t square plus 3 xz. X is t, z is t cube, that is 3t power 4, and dy value 2t dt plus 1 minus 4 into x is t, y is t square, z is t cube, z square is there, so it becomes t power z is t. So integrating with respect to t, so next slide, and multiplying the totally, taking dt common and integrating, will get, and applying the limits, will get the value as 2. Okay, we will continue in the next class. Today, so one more time, I'm sorry for this weather condition. My internet problem is there. So for sorry, but the next class we have on Saturday, we'll continue with this, and I'll try to explain the important questions, and I'll give the important questions also. What the CR numbers I have, I sent the last PDF form of that, and today I will send this important questions also. Please, I have only CSEA CR number and CSE CR number, ITB CR number. So I will pass on my notes and important questions to that. Please collect from them, those who are interested. Or if you have notes, please take my number from the UNASA